Unit 6, here we go. So we're gonna this lesson is gonna be nice, especially after the last unit and test, because today's lesson, is 100% review. Everything in this lesson is review, and it's fairly straightforward. So let's dive on in with some examples and some things. So put all of these things up on the chart. So we're doing function operations, as the title suggested. Excuse me. We've done this before. I feel like we've done this in Algebra 2 before, but definitely done it in Algebra 1, if nothing else. And so we can take and smoosh functions together in different ways. That's basically what we're talking about here, right? So if we have, and this is just this slide essentially is just notation, right? If you have f plus g of x, and that's the same as f of x plus g of x. Same thing for minus, it's f of x minus g of x, and times and divided by. All of these are you when you have it looking like this, you just take one function and then you either add, subtract, multiply, or divide the other function depending on the symbol. We'll do some examples to keep dusting off those cobwebs. And then composition of functions is another type of function operation, and that's if we have f. And the way we read this, I'll put this as a note here. If we have this, the way we read this one, these are a little more obvious, so I think we can just handle that, right? But this we read as f of g of x, right? That's how we read this here. We don't read it fog, we read it f of g of x. And what it is you take g of x, the whole function, and you shove it inside of the other function. And g of f of x is taking the f of x function and shoving it inside of g of x. We'll do some examples to keep dusting off those cobwebs and all of those things in a moment. But that's what we're looking at there. Let's dive into examples and see if we can kind of clean up some cobwebs, right? So we have given this function, f of x equals x squared minus 4, and g of x equals 2 of x plus 1. We want to find each one of these functions. So we're going to find f plus g of x and f minus g of x. So this is f of x and this is g of x, right? So for this one, this is the same, we just saw, as f of x plus g of x, right? It's the same as that. So we're gonna stick down f of x. So f of x is x squared minus 4. I'm gonna put this in parentheses. We'll probably drop these in a moment because it's gonna be plus on this one, but to help remember what we're doing, especially for this example, that's why I'm doing that. Anyway, plus g of x, which we're also going to put in parentheses, so 2x plus 1, right? So now we just need to combine these, make it prettier, make it not ugly, right? So since this is a plus out here, these parentheses don't actually do anything on this problem, right? So we can just rewrite this. I'm going to go ahead and rewrite it in descending order because we've got lots of practice doing that. Right, so x squared plus 2x minus 4. Just watch your signs when you're using that commutative property, and then plus 1. Do we have any like terms? Yes, we do. This one and that one. These are not alike, right? This one's a squared. This one's not a squared, so they're not alike. So our answer to f plus g. What am I writing? What is this nonsense? F plus g of x equals x squared plus 2x minus 3. Right? That's pretty straightforward. Let's look at this one. So f minus g of x is the same as f of x minus g of x. So this one, because it's a minus, right, the order is really going to matter. It's going to be really important that we keep the order right, and we're also going to want to make sure we distribute that negative if we need to. Well, let's do it. So f of x is x squared minus 4. I'm going to do just like I did over here and put each one in parentheses, and then minus all of g of x. And this is what I'm talking about. This is where we might run into issue if we don't take the time to do that. This is a place where we could easily make mistakes, right? Because it's minus the entire function, right? And so that's really important because this negative now has to be distributed, Okay, so we're going to distribute this negative over here. So let's bring this one down. There's nothing in front of this one. We can just drop these parentheses. So x squared minus 4, and then minus 2x minus 1. Right? Do we have like terms? Yes, we do. This one and that one. So if we write it in descending order, which is what we want, f, I keep doing that. I don't know what I'm doing. F minus g of x equals x squared minus 2x minus 5. Easy peasy. I told you it wasn't too bad. It's not too bad. We got this. All right, let's do the next function. So we've got some multiplication and division this time. So given f of x being that function, g of x being that function, find each function, indicate any restrictions on the domain or range. This bit of the instructions could have been on the last thing. It doesn't change anything, except this one in particular, one of these, you're going to note that the domain can't include everything. It's not all real numbers. We'll show you what we mean. So this one right here, f times g of x, is the same as f of x times g of x. So we're going to kind of do just what we did last time. We're going to write down the function. So f of x is x squared plus 7x plus 12 and times g of x, which is 3x minus 4. What do we got here? We got the big old distributive property, so we want to take care of that. So we need to go and deal with that. So we're going to distribute this on both of those. We're going to distribute this on both of them and this on both of them, right? So x squared times 3x is 3x cubed, right? X squared times x is x cubed. X squared times minus 4 is minus 4x squared, right? And then, so we did that one, right? We're going to go to this one. 7x times 3x is plus, so positive, 21, because 3 times 7 is 21. X times x is x squared. 7x times negative 4 is negative, because positive times negative is negative. Negative 28, because 4 times 7 is 28. And there's just 1x. Great. And then we did all that one. We're going on to the 12. So 12 times 3x is plus 36x. 12 times negative 4 is minus 48. Do we have any like terms? Let's take a look. I bet we do. In fact, we have one right there with that one. And then these two are alike as well, right? So f times g of x equals 3x cubed plus, say, negative 4 plus 21 is 17. 17x squared, right? And then negative 28 plus 36 is 6 plus 2 is 8. So 8, right? Plus 8x minus 48. I tried doing that in my head without you here to catch my mistakes. So if I made a mistake, you're going to have to let me know in the comments or something, right? Or in class is fine. There we go. All right. That's perfect. Let's do this one. So this is the same as f of x divided by g of x. Easy peasy lemon squeezy, right? So we're going to put in the top, we're going to put f of x, which is x squared plus 7x plus 12. And we're going to put that over g of x, which is 3x minus 4. And so this is the answer. Now, this one is the one where we have a restriction on our domain. So there's kind of more to the answer, because if we take a look at this thing, we've got a fraction there. What can we not have in the bottom of a fraction? We can't have 0 in the bottom of the fraction. So in order to figure out our domain restriction, we need to set that denominator equal to 0. So 3x minus 4 equals 0. If you're getting at this point in Algebra 2, by the way, just throwing this out there for my own personal students and whatever else, if you're getting at this point where you can take a look at a two-step equation and write x equals 4/3 and move on with your life, go for it. I'm not gonna hold that against you, right? So, but in this video, I'm gonna continue to walk the pieces, right? So plus 4 plus 4. So we've got 3x equals 4, and then we got to divide by the 3. Is going to be x equals 4/3. So what that means is x cannot equal 4/3. So x cannot equal 4/3, because if it does, then we've got a problem, right? We'll learn more throughout this unit of kind of what that means, and if we were to graph this thing, what it would look like, and all the things. There's all kinds of different puzzle pieces involved here, right? So let's do the next thing. We got some composition happening here, right? So we've got this f of x, and we've got this g of x, and we want to find f of g of x and g of f of x, right? So for f, and you may be like, why is it in brackets this time? Because it is. It doesn't really matter. Brackets, remember, brackets and parentheses are the same thing. Just wrote it different type of clarity in this particular problem. This is the same as f of g of x, right? So we've got to take f and put g of x inside of it, right? So what we're going to do is we're going to write f with parentheses wherever there's a variable, right? I made it big because we've got to put all of g of x in there. So we're going to take and put g of x inside of there. So we're going to take, and g of x is this. So we're going to put 4a inside of there. Now we just need to clean the thing up, right? So 2 times 4a is 8a. And then bring down the minus 5. So f of g of x equals that. Easy peasy lemon squeezy. Now let's find g of f of x. So g of f, I didn't even mean to write regular parentheses, but we're going to roll with it because it doesn't matter. That is the same as g of f of x, right? So we're going to take g and write it with parentheses where the variable is. So 4 and then open parentheses. Then we're going to take all of f and put it in there. So we're going to take all of f, so 2a minus 5, and put it in there. So now we're going to clean it up. This time we've got a distributive property, right? We've got this, and we've got to distribute right there. So 4 times 2a is 8a. 4 times negative 5 is negative 20. So g of f, and just to mess with some of y'all, g of f of x equals that. And that's it for this lesson. Easy peasy, not a difficult one. If you're one of my students, I'll see you in class. If you're not one of my students, thanks for joining us. Let us know how else we can help you. Don't forget to hit like and comment and subscribe and all those things. Thank y'all very much. Bye-bye.